Good afternoon, students. Today's session I am going to discuss about finite automata with epsilon transitions. Here already you know that what do you mean by DFA and NDFA. DFA means deterministic finite automata, whereas we are going to give the input symbol and we are going to get one output symbol, single input and single output. For example, for DFA, here for example q naught state is there. Whenever I am going to apply 0 input and then we are going to get q1 state, right? Here 0 input and any state we are going to get one output state, that is q1. This is the DFA, right? This is the DFA. Whereas in case of NFA, here whenever we are going to apply any input and any state, we are going to get multiple number of states for the same input. We are going to get multiple number of states for the same input. This is the NFA, right? We can extend this NFA by using this epsilon transitions. By using the epsilon transition. Here already I told that what do you mean by epsilon? Epsilon is a null string. Epsilon is a null string, right? Here we extend this NFA by using this null string, but here in NFA we are having the epsilon transition, whereas in case of DFA we don't have any epsilon transition. We can't process the empty string on the DFA, whereas in case of NFA we can process the empty string on the given NFA. Whenever we are going to perform the empty string on the NFA, then that particular NFA is known as the NFA with epsilon moves. NFA with epsilon moves. Here in general we can't process the epsilon transitions on DFAs. Here we can perform the epsilon moves on the NFAs, right? Here whenever we are going to use this epsilon transitions on NFAs, then that particular NFA becomes the NFA with epsilon moves. Here the automation may be allowed to change its states without reading the input. In the previous session we discussed that whenever the state is going to read any input symbol, then only it is going to change its states, whereas in this case here without reading the input symbol also, the automation is going to change its states in NFA with epsilon moves. Here and the epsilon transition means here we are not going to give any input symbol. Epsilon is not the input symbol. We are not going to recognize that epsilon as an input symbol. Here see, here in the given example, here 0 is the input symbol, here 0 is the input symbol. In some cases 0 comma 1 comma 2 is the input symbol. In some cases a comma b is the input symbol, right? But here epsilon is not the input symbol. Epsilon is not the input symbol. And we can process the epsilon. But we are not going to include in the input symbol. Here everything is same as just like the NFA, but only the difference is in epsilon NFA we are having empty paths. Path, or else the null string is going to process that particular state, right? And see here, check this 7th point. Delta of qi comma e denotes for every qi state. Here qi into a dead state f if there is no next state with e as input symbol originally. Here if we are not having any input symbol, if we are not going to apply any input symbol on any state, then that particular state is known as the dead state. In such cases, if we are going to apply the epsilon symbol on that particular state, here state is going to be changed, right? Generally here DFA compared to NFA, DFA and NFA with epsilon moves, here DFA is more powerful. DFA is more powerful, and here it is no more powerful than the normal NFA. Then DFA, NFA, then epsilon, NFA with epsilon moves. Yeah, DFA, NFA with epsilon moves. Yeah. DFA is compared to NFA, DFA is more powerful. Compared to NFA with epsilon moves, this NFA is more powerful. Yeah. Here, NFA with epsilon mu is going to satisfy each and every property of the NFA except in its transition function. And one more thing, this NFA with epsilon mu is going to process the empty string also. See. Then, what is the use of this epsilon transition? Where we are going to use this epsilon transitions here? Here, epsilon transition means we allow the automation to accept the empty string. Here, whereas in case of DFA, we are not going to allow any empty string. Where any input symbol is there, that particular input symbol is going to process on the DFA. Then we are going to recognize whether that particular string or whether that particular language is going to be accepted by the DFA or not. That's it. We are going to check in the DFA. Whereas in case of NFA, here for the same string, we are having multiple number of states, right? Till now we are not going to process any empty string, but in this case in NFA with epsilon mu, we are going to here automation is possible by using the epsilon mu, by using the empty string. In some cases some finite automata is going to accept the empty string. In some cases finite automata is going to accept the empty string. Here whenever the finite automata is going to accept the empty string, it means that the transition is allowed to occur without reading a symbol. Empty string doesn't contain any symbol, right? Is it right? For example, any string is there. For example, string is there, A, B, C. String is there. This string is consisting of various types of symbol. One A symbol, one B symbol, one C symbol is there, right? A comma B comma C symbols are there. Whenever I am going to process this particular string, it means that here the string is going to read by that particular DFA, right? Whereas here I am processing the empty string. It means that here that particular transition doesn't have any symbol. Then this type of NFA is known as epsilon NFA. This type of NFA is known as the epsilon NFA, right? Here, why we are going to use this epsilon NFA? For our convenience. In some cases, if we want to change the state of the particular machine, in that particular case, we are going to use this epsilon transition. Epsilon transition means reading the empty string. Epsilon transition means reading the input empty string. Right. Now go for the definition of epsilon NFA, epsilon with emus. Here already I told that in DFA you have to, in DFA, in NDFA, in NFA with epsilon mu, in each and every case you have to remember the tuples where we are going to use. Here in DFA we are going to have 5 tuples: Q, sigma, delta, Q naught and F. Q is the set of states, sigma is the set of input symbols, delta is the mapping function. In DFA, mapping function is Q cross sigma into Q. Then Q naught belongs to Q. Q naught is the initial state. Next one is the F subset or equals to Q. F is the set of final state. Right? This is the case of DFA. Whereas in case of NFA is having 5 tuples: Q, sigma, delta, Q naught and F. Same, Q is the set of states, sigma is the set of inputs, Q naught, delta is the mapping function. Here Q cross sigma into 2 power Q. 2 power Q is the power set of Q. 2 power Q is power set of Q. Next, the Q belongs to Q. Q naught belongs to Q is the initial state. F subset or equals to Q is the set of final state. Up to here, this is the definition of NFA. Now here NFA with epsilon mu. Is here, this NFA with epsilon mu is the extension of NFA. It is the extension of NFA. In this case, it is also consisting of 5 tuples: Q, sigma, delta, Q naught and F. Here Q is a finite set of states, sigma is a finite set of input alphabets, right? Here delta is a mapping function. This mapping function is mapping from Q cross sigma union epsilon. Q cross sigma union epsilon into 2 power Q. Whereas in case of NFA, what is my NFA? Delta function Q cross sigma into 2 power Q. Here NFA with epsilon is the extension of NFA. Here we are going to use the empty string. That's the reason Q cross sigma union epsilon into 2 power Q. Right? Here Q naught is the initial state. Q naught is the initial state from where any input is processed, right? Q naught is the initial state. F is the set of final state. F is the set of final states, right? This is the definition of epsilon, NFA with epsilon moves. See here, check this one. Here, this is the example of NFA, right? Here, in this case, how many states are there? Q, R, S. Here, for example, I am going to draw the transition table for this one. How many input symbols are there here? 0, 1. Right? Input symbols are 0, 1, and one more input symbol is there, that is epsilon. That is epsilon. Right? Yeah. How many states are there? Q, R, S. Which one is initial state? Initial state is going to be indicated by this arrow. So here, initial state, which one is the final state? S is the final state, indicated by the double circle. So S is the final state, right? Q naught on 0, Q naught on 0, sorry, Q on 0, S. So S. Q on 1, R. Right? Q1 epsilon. Is there any epsilon transition is there for this Q? No. So empty dash. R on 0, Q. R on 1, R on 1. Is there any epsilon transition is there for this R on 1 transition is there? No. Dash. R on epsilon. Here epsilon transition is there. See here, epsilon transition is there. S. S on 0, S on 0. Is there any S on 0 is there? So no. S on 1, Q. S on epsilon, R. In general, we don't have any epsilon transition, but here in NFA with epsilon moves, we are having three input symbols 0, 1, epsilon. We are going to process the input string also, right? This is the transition table for the given transition diagram. Right? Here, see here, this is one more example. See here, number of states are there. Here epsilon is there. Here also epsilon is there. Here, how many number of input symbols are there? W, E, B, E, B, A, Y. Number of states are 10. Number of states are there. Here, starting state is 9. Ending states are, final states are 4, 8. 4, 8. Right? Yeah. This is also one type of epsilon. Already we explained this one. Epsilon with NFA with example. Here we can process the string on the particular data. We can process the string on the particular given NFA. For example, here I am going to check whether the string 0, 0, 1. I am going to check whether the string is 0, 0, 1 is going to be accepted by this NFA with epsilon moves or not. NFA with this one. Here, see here, whenever we are going to process any input string, we have to start from initial state. Which one is the initial state here? Q is the initial state here. Q on 0, Q on 0. Which state? Here we are getting here Q on 0, Q on 0. Which state we are getting? S, right? Q on 0 is S. Now, S on 0, S on 0. Is there any S on 0 is there? S on 0. Here, see here, in the previous example, S on 0 is not there. So, here, in this particular case, we are going to check. See, I'll explain here only. What is my input string? 0, 0, 1. See here, my input string is 0, 0, 1. My input string is 0, 0, 1. Now, which one is initial state? Q is the initial state. So, Q on 0 is S. S on 0, is there any S on 0 is there? S on 0 is not there. Here null is there. So, we are going to check for the epsilon transition, whether any epsilon transition is present in here for this S or not. Here S on epsilon transition. This is the null string. Just we are changing this state. Already I explained that here what is the use of epsilon transition means. Just we are going to changing this state. Just here I am going to change this state from S to R by using the epsilon transition. Here epsilon means null string, right? Right. Here epsilon means nothing, that is the empty string. We can change this state by using this S to epsilon. Here whenever I am going to apply epsilon on S, here I am going to read the S state. R on 0. Now I am going to check for this R on 0. R on 0. What is R on 0? Q. R on 0 is Q. Right? R on 0 is Q. Right? Next 1. Here Q on 1. Is there Q on 1? Any state is there? Q on 1. Yes, Q on 1 is R. Q on 1 is R. Now here this is my string 001. Now I am going to check this string whether this string is accepted by this NFA with epsilon moves or not. When we are going to set this, that particular string is accepted if that particular string is going to reach the final state, then only that particular string is going to be accepted. In this case, here I am reaching S. In this case, I am reaching R. Here, by using this epsilon moves, I can change this state. By using this epsilon move, I can change this state. See here, epsilon S. I am reaching the final state. So, this particular string here, whenever we are going to reach the final state, it means that this string is accepted. This string is accepted by NFA with epsilon moves, right? The string is accepted by this epsilon moves. Here epsilon is the empty string. Here indirectly we can write this 0 epsilon 0 1 epsilon, right? Instead of 0 0 1 we can write 0 epsilon 0 1 epsilon. Epsilon means null string. Epsilon means null string, right? Here in next session I am going to explain about epsilon mean epsilon NFA, epsilon conversion of NFA with conversion of NFA to conversion of NFA with epsilon moves to without epsilon moves, and conversion of NFA to DFA. Right? Thank you.